Now in S1 you worked out how to calculate the mean and variance for discrete data, but this video is about working out the mean and variance of a continuous random variable. Remember that discrete data is generally speaking whole numbers, but continuous variables can take any number in between numbers, 3.275, a height or a length or a time, something like that. So we're looking at the mean and variance of continuous data. Now the mean is the expected value, and the expected value we saw in S1 for discrete data is sigma px, where p is the probability of x occurring. Now for continuous data, the sigma sign is replaced by the integral sign, and the probability is replaced by the expression for the probability density function. So the mean works out to be the integral of x fx dx over all possible values from minus infinity to infinity. Now let's do a similar thing for variance. The formula for variance is the expected value of x squared minus the mean squared. So for discrete data, the formula that we had was sigma p x squared minus mu squared. That's for discrete data, but as before, the integral sign replaces the sigma sign, and the probability density function replaces the probability of x. So where we've got this for discrete data, for continuous data, we get the variance of x is the integral of x squared f of x minus the mean squared, and the integral is over all possible values. So this is for discrete, and this is for continuous. So let's look at this example here. We've got a random variable, it's got a probability density function, and we need to find the mean and the variance. So the mean, as we said before, is the integral from minus infinity to infinity of x fx dx. So in this case, that's from 0 to 2 of x. Then f of x is 3/10 3x minus x squared dx. So let's multiply it out. 3 times 3 is 9, so it's 9x squared over 10 minus 3x cubed over 10 dx. So that works out to be, if we integrate it, we get 3x cubed over 10 minus 3/40 x fourth. That's from 0 to 2. Substitute in 2, take away 0, and it works out to be 6/5. So that's the mean. We need to do the variance. So firstly, let's work out the expected value of x squared, and then we can take away the mean squared later. So it's from 0 to 2, it's x squared, and f of x is 3/10 3x minus x squared. So 3 times 3 is 9, so it's 9x cubed over 10, still at the integral stage, minus 3x to the power 4 over 10. Integrate each bit separately, and we get 9/40 x to the power 4 minus 3/50 x to the power 5 from 0 to 2. Substitute in the values, and we get 42 over 25. So to work out the variance of x, that's the expected value of x squared minus the expected value of x all squared. So that's 42 over 25. The expected value of x was 6/5, so it's that squared. That works out to be 6/25. So now let's look at this example. Again, I've got to work out the mean and standard deviation, but this time the probability density function is in two sections. So we can integrate each bit separately, but there is a slightly quicker way which involves a little bit less work, and that's to look at the graph of this function. So the graph of the function looks like this. So we can see straight away by symmetry that the expected value of this is going to be 2. So the expected value of x equals 2. However, there's no equivalent shortcut to work out the standard deviation, so we're going to need to do the integration. So the formula that we get is integral of x squared fx dx. So it's in two sections, so from 0 to 2 it's x squared times a quarter x dx, and from 2 to 4 it's x squared times a quarter 4 minus x dx. So we are going to need to simplify these expressions, so that's 1 quarter x to the power 3 plus a quarter of 4 is 1, so that's x squared minus a quarter x cubed. So then we integrate each bit separately, so that's 1/16 x to the power 4. So 4, there it is, that's from 0 to 2. And then we get a third x cubed minus 1/16 x to the power 4, that's from 2 to 4. Substitute in those values, we get 1, we get 11 thirds, so altogether it's 14 thirds. So the variance of x, which is the expected value of x squared minus the expected value of x all squared, is 14 thirds. The expected value of x was 2, so take away 2 squared, that's 4, so we get 2 thirds. And now here's our final example. Similar sort of thing, that we've got this probability density function that we saw before, and this time we've got to find the probability that x is less than mu minus sigma. So we need to find the probability that x is less than mu, which is 2, minus sigma, which was root 2 thirds. Remember the variance was 2 thirds, so the standard deviation is root 2 thirds. So we could use integration to do this, but because the graph is a straight line, it is actually going to be much simpler to use geometry. Now, 2 minus the square root of 2 thirds works out to be 1.183504. So what we actually need to find out is this area here. So how do we find out the area of a triangle? Well, it's half the base times the height. So the probability that x is less than 1.183504 is a half times the base, which is, let's do it exactly, 2 minus root 2 thirds. And then the height, well, the height is given, is this here obviously, and the height is given by this expression here. It's a quarter x because it's between 0 and 2. So it's a quarter of x, and x is 2 minus root 2 thirds. So we need to work that out, and it works out to be 0.175 to 36 figs. Obviously that's quicker than doing the integration, which we could have done. And that's it.